So welcome to this segment as we try to look at the question. Sorry, I think it was rightly answered in, but it says study the energy level diagram shown in 1 and 2. So they have shown you the energy level diagram. So remember, it says on the diagram 2, label the part which shows activation energy. So activation energy should be labeled from the reactant, to the highest point of the hue called the transition state. So you draw an arrow having double arrows from the reactant to the highest point. If I thought they also wanted me to show there, it would have actually been from the reactant up to the transition state. So that represents the activation energy. But they wanted you to show the activation energy, on the diagram 2 there. And then what is meant by activation energy? Activation energy is simply the minimum amount of energy needed to start a chemical reaction. So for the reactant particles to react, they need the lowest or the minimum amount of energy, and that minimum amount of energy is what we call as being activation energy. So this is what we defined there. Then it says methane burns in air according to the equation. So methane plus oxygen produces carbon dioxide and water, and then you can see that the enthalpy change is negative 880 joules. Because of that negative, that tells you that this is an exothermic reaction, and it is true for all exothermic reaction, the enthalpy change is actually negative. Yeah, so from the diagrams there, you can see this one that we have here is simply diagram 1 is representing an exothermic reaction, and this one is representing an endothermic reaction. So that's what we mean there. Then it says which of the levels labeled A, B, C, or D will the following be placed? Methane and oxygen. So methane and oxygen will always go on the reactant because this is an exothermic reaction like we have identified, then it will go at A. This is where you are supposed to have CH4, then you are supposed to have your oxygen on the reactant. Then carbon dioxide and water on the product side, so that is going to be B, which in this case is carbon dioxide plus H2O. So that's what they wanted us to state. Then of course you need to remember that from the reactant, if the arrow goes down, this is what we call the enthalpy change, and for that it is always negative. In this case here, so you draw the arrow from the reactant up to the product going in one direction. You have seen I've also drawn in one direction, very important. So that is the enthalpy change, and the enthalpy change there is actually positive. Then apart from the CH bonds broken, which other bonds are broken? So from the methane, like I've drawn here, it consists of CH bonds. So the CH bonds have been broken, but there's oxygen containing a double bond, so that has also to be broken. So the double bond was the answer. Which diagram represents the combustion of any fuel? So it is actually diagram 1 there. So that represents the combustion of any fuel. And in a combustion reaction which is exothermic, the energy of the products will always be less than the energy of the reactant. So basically this is what you needed to do. Please watch out some other videos on, I'll show you how to calculate bond enthalpy. Thank you so much.